Okay, guys, I want to take a look at a few more examples of inputting and outputting code today. Okay, so take a look at the output that this program generated here. What was your test mark? 78. What was the test total? 83. What part of this is forming the input? You said the first two lines, you're right. The program needs to ask for what was the test mark, and it needs to ask for what was the test total, right? So that's the input. And then what makes up the output? The last two lines of the program. Clearly, there's been a calculation here to figure out what the test mark was, right? But that's not part of what's displayed on screen. Okay. What type of data is being input in this program? There's no decimals for these marks, so it's an int. Okay, and how many variables would we need in this program? I need one variable for the 78, the test mark. I need one variable for the test total, the 83, and I need a third variable for the 93, the percentage that the person got on the test that was calculated. If you take a look at the code that I've brought up on the bottom of the screen there, what are the variable names that match up with the different values? We've got the first variable called integer mark, and that matches up with the 78. We've got an integer called total, and that matches up with the 83. We've got an integer called per for percent, and that matches up with the 93. Now, I didn't write this code. Personally, I would use the whole word percent rather than shortening that word down. It's not that much to type. If you look at the first system.out.println, it has a /n as the first thing on the line. What does /n do again? That's what created the blank space on the program output there. Right? /n is the new line character. So that system.out.println said, the first thing I want you to do is print a blank line. Then I want it to say that was whatever the value of per is and a percent sign to go with it. There's one other thing that I want you guys to notice about this program. The percent variable is an integer variable. So even if the grade would calculate as something that should be a decimal number, Java will cut off the decimal values and just give an integer value, right? So if you scored 7 out of 9, that should come out as 77.7777%. And Java will chop the decimal values off, and it will just say 77. It wouldn't even round to 78. It just chops the values off if you make percent a integer value. Now, if you wanted to show some decimal places, you could always use a double there. Here's another program. This one is calculating the surface area and volume for a cylinder. Now, the surface area and volume of a cylinder are determined by the radius and the height of the cylinder. So we're going to ask the person to input the height and the radius and what unit they measured in. Maybe that was measured in centimeters, but maybe it was measured in inches or, I don't know, kilometers. What type of variable would I need for each one of these? Because I have decimal places for 4.2 and 3.4, those need to be double. And because the unit is characters, but more than one character, that needs to be a string. What other variables is this program going to use? The surface area has been calculated somehow, so I would need a variable for that. And the volume has been calculated, so I would need a variable for that. And here's some code that carries out this program, right? The first line prints the sort of the title there, cylinder surface area and volume. And notice the /n again gives me that extra line of space to make it look a little bit nice. Then I am doing some input for the height, the radius, and the units. And after that, I have two lines making the calculation for surface area and volume. Notice something about these two lines. That part of the formula for the surface area of a cylinder and the volume of a cylinder uses pi, right? 3.14, right? We can actually write math, capital M on math, dot pi to get the computer to use the most accurate version of pi that it knows. Right? You could write 3.14 in the formula, but math.pi will be correct down to about 15 or 16 decimal places instead of just two. Right? So that's what math.pi is doing for us there. When I create a program in Java, every time you add a new class, remember a class is like a whole complete program. We've gone one of two ways throughout the course so far. You'll notice in some of the different starter code. It always starts with public class, whatever the name of the class is, and that should technically have a capital letter C on cylinder. And I always need to have a public static void main. Now, sometimes in a Java program, it's considered a good programming style to not actually write all your code in the main method, but to write it as a part of a separate method. So what's happening in this program, the main method is just creating a new cylinder program running in memory. That's basically what that line says. Make me a new cylinder program. And then to tell Java how to make a new cylinder program, it looks at the public cylinder method, right? Notice that all three of the names match. If you were going to save this program, you would want it to be saved with the same name as the class name. So it would have to be saved as cylinder. And that word has to match in all three places there. Public class cylinder. Give me a new cylinder because it needs to match the program name. And public cylinder, this is how you do the cylinder program. And then all the code for that can be in there. It doesn't make too much difference to me at this point in time if you write that code straight in the main or if you use this call to a constructor method. The program will execute basically exactly the same. Right, so now where's the main method? It's at the top of the program there. And this public cylinder method, we would call that a constructor method. It constructs the program in the computer's memory, if you want to think of it that way. Right, and so that's the whole constructor method. And the last thing I want to focus on, okay, where's the class? The class is the entire file. What do we use the braces for? The braces are those fancy curly brackets. There's a pair that starts with public class cylinder, and there's a brace and a brace at the end. There's a pair that goes with public static void main. I don't like the style here having the line on the same, the line new cylinder on the same line as the brace. I'd rather have them more the way they're laid out in the public cylinder method. But there's a pair of braces there, and there's a pair of braces for the public cylinder method going from the top of it to the bottom of it. What do the braces do? They define regions of code within the program, right? And now that they're color coded, you can sort of see what regions each set says. The blue ones, this is the public static void main method for the program. These green ones, this is how you do a cylinder for this program. And the red ones, this is where the whole class is, from the very top of it to the very bottom of it. Second part of today's lesson, I just want to take a look at a little bit of example code in Eclipse. If you follow baseball at all, you'd know that there's tons of statistics that they collect in baseball. One statistic that tells you sort of how good of a batter somebody might be is their batting average. But another statistic that people use is called the slugging average. And I'm making a little program here to try to calculate the slugging average. The difference between batting average and slugging average is slugging average tries to capture not only how often somebody will hit the ball, but also like how many bases they'll run when they hit the ball. So it weights different kinds of hits just a little bit differently. You notice that I've already started my program. I made my Java project. I included the Java or the io.java file, and I've started my slugging program. I went ahead and found a fancy font to make a nice title for my output, and I've put the inputs that you need in order to calculate the slugging average. To calculate the slugging average, you need to know how many times a person's been at bat, how many singles they hit, how many doubles they hit, how many triples they hit, and how many home runs they've hit, right? So if I was to run this program now, it says slugging. It says how many at-bats have you had? Maybe a person's had 20 at-bats, including, I don't know, somebody who's really good. 8 singles, 5 doubles, 2 triples, and 4 home runs. Whatever. That would be a pretty outstanding player. Program doesn't calculate anything yet because I haven't added any lines to make the calculation. And that's what I wanted to talk about this part of the lesson. How do we actually calculate? It's going to be a double because it's going to have very much a decimal type of answer. But how do I calculate somebody's slugging average? Just sort of given that information. Well, the slugging average is going to be first look at all the different types of hits that they got. We're going to add how many singles did the person get, plus, now if you hit a double, you run 2 bases, so they do 2 times how many doubles did the person hit. And for a triple, that's 3 bases, so they give that a score of 3 in the weighted average here. And a home run is 4 bases, so those are worth like 4 points in the average here. All right, so I'm looking at singles, 2 times the number of doubles, 3 times the number of triples, and 4 times the number of home runs. I take all that information and I divide it by how many times a person was at bat. And whatever that comes out to, that's what's known as the slugging average. What I want you to notice about the calculation that I'm doing here in Java is a little bit of how the math works. I say the variable name, and then I can put an addition sign to add different variables together. If I'd like to multiply by a number, I use the star to multiply. If I want to divide by a number, I can use slash to do divisions, the backslash. And of course, if I wanted to subtract numbers, I could put the subtraction sign as well. So math kind of works, I don't know, as you would expect it to, as you would write down some sort of expression for math. What Java is going to do is it's going to look up what's the value for singles, and it's going to look up what's the value for doubles and multiply that by 2. What's the value for triples? Multiply that by 3. What's the value for home runs? Multiply that by 4. Add all that stuff together, and because I've put it into the set of brackets, it will add all those things together first, and then it will divide by how many at-bats the player has had. And the last thing I need in my program is a little output to say what's their slugging average. So system.out.println this player's slugging average is and whatever I calculated as the slugging average. So if I run that again, I'll try to be a little bit more realistic here. A very good player may have had, let's say, 50 at-bats, probably only got about, well, let's say 15 singles. They don't tend to hit too many doubles, so let's say like 5 doubles. Triples, they don't tend to hit as many either. Let's say 2 of those. And surprisingly, people usually get more home runs than they do triples. So let's say 4 home runs for this player. And it comes calculated out as, oh, I got a 0. So I have a little bit of a bug in my program. And I'm going to let you know where that bug came from. I said that slugging should be a double, but all of the values that I'm calculating with are integers. Singles is an integer, doubles is an integer, triples is an integer, home runs is an integer, and at-bats is an integer. Now, whatever the value is when I calculate it, it's something less than 1, right? So that entire calculation comes up to, let's say, 0.8. And it did not come out as a value that shows up as a double, because Java went, oh, all these things are int variables. I'll do integer division. And then the very last thing I'll do is store that into the double that I called slugging. If I want to force Java to do double calculations, so keep all the decimals during the calculations, then what I should do is put in brackets in front of the calculation that I want the answer to come out as a double, not an int. Right, so now even though, yes, all those variables are int variables, Java is going to turn around and sort of treat them like doubles and allow for decimal places. Right, so that should correct my little error that I had going on in my program. I'll try it one more time here. 50 at-bats, 15 singles, 5 doubles, 2 triples, and 4 home runs. And that comes out to a slugging average of 0.94. Notice if the average was 0.94, when Java was acting as integer calculations, it chopped off the decimal place. It didn't even round up to 1. It chopped off the decimal place and just reported that average previously as 0.0 because it was doing integer math instead of doing double math. All right, so to make calculations within your program, you can use basically any normal math that you would use: addition, multiplication, subtraction, division. And if you need to have an answer that includes decimal numbers, you might need to say in your statement about the math that you want double values. All right, good luck with the programming assignments for today. There are 2 of them if you look on the course site that ask you to get some input, make a calculation with that input, and then display the output. And I will be back on Wednesday to help you out if you're struggling at all.